vCD to vCD is the primary disaster recovery as a service topology for cloud service providers and managed service providers operating in multi-tenant environments. It enables tenants to replicate their vApps between two vCD-managed sites within the vCD abstraction layer and without exposing the underlying vSphere infrastructure. In this demonstration, I will present a live failover operation using HPE Zerto between two VMware Cloud Director environments. Here we have the basic architecture. We will replicate the virtual servers associated with a vApp to another recovery site. From HPE Zerto's perspective, vApp is not a simple VM object, like in vCenter. It's an application container controlled by vCD. Therefore, HPE Zerto can protect vApps as cohesive units within a virtual protection group, ensuring application consistent protection for all VMs associated with the vApp. vCD integrates with Zerto organizations to enforce tenant boundaries. Each tenant's VPGs, resources, and recovery operations are scoped to their organization, preventing cross-tenant data exposure. It's essential for MSP compliance and security. In this example, we have created Organization 1 and the VMware Cloud Director resources. The virtual data centers are associated with it. In this case, we are associating the Virtual Data Center 1 or ORGVDC1 with both the source and destination sites. Here we can see the Ubuntu vApp configured on the production side. We can also see that there are no vApps configured on the recovery side. In the vApp on the production side, we have two virtual servers that are configured and powered on. We will replicate this vApp using HPE Zerto and then perform a failover to the recovery site. We already have a virtual protection group configured and replicated to the recovery site with an RPO of approximately 10 seconds. Let's edit it to understand its properties. In the general step, specify the name of the VPG and the priority of the VPG. The next step is to select the vCD vApp to protect in this VPG. The protected virtual machines are presented in the right space. It's necessary to define the replication parameters. Select the recovery site and the organization. You can keep the default parameters for journal. In the VM settings, you can change the VM storage profile and specify the hard limit size for the journals and scratch disks. For each virtual machine in the VPG, Zerto displays its storage-related information. You can change it if necessary. You can define the vCD recovery settings and the vApp networking map. In this example, we use the direct network as the source network. It is also used for failover or a move operation at the recovery site. The isolated network is used during a failover test. It's a non-disruptive, fully reversible DR drill. This network is also being used for reverse failover tests. You can also change the NIC properties for each VM. For example, to recover VMs with different MAC or IP addresses. These are the basic configurations. Let's cancel the addition. Now let's start a live failover. We select the VPG and click on Next. You can edit the checkpoint and select any timestamp you need. It's also possible to select checkpoints using tags to identify specific events. You can define a commit policy. In this case, auto commit after 60 minutes. It's also possible to shut down the production VMS automatically after the commit action. Reverse protection is the process of automatically flipping the replication direction after a failover live is committed. The VMs now running at the former recovery site are immediately protected back toward the original site. You can edit the reverse protection parameters. For example, by modifying the VM storage profile and storage policy as needed. This flexibility in the reverse protection procedure is a major advantage of the solution. After the reverse protection addition, click Next and start the failover operation. The failover before commit operation will start. After the reverse protection addition, click Next and start the failover operation. The failover before commit operation will start. It is a temporary paused state where the recovered VMs are already running at the recovery site, but the operation hasn't been finalized yet. It gives you a window to validate that everything is working before deciding to commit or roll back. In the meantime, the production VMs are powered off. You can access the VMs at the recovery site and verify whether they are in the desired operational state before the commit action. We can access a Ubuntu VM and perform a validation. As we can see, this Ubuntu VM is operational on the recovery site, so we can proceed with the commit. The reverse protection is enabled, and the commit process began. Under the hood, Zerto will perform a promotion process. The scratched journal and replica disks are consolidated into production disks and attached to the VMs. Here we have a representation of the architecture after the commit and promotion processes. The vApp and the VMs are powered on at the recovery site and are available for use. At the former production site, journal and replica disks have been created for reverse protection. Zerto reuses the former production VM disks at the original site as pre-seeded replica disks, instead of copying everything from scratch. The solution reads the former production VM disks at the original site by data store path as a pre-seed baseline without detaching them from the powered-off VMS. It synchronizes only the changed blocks between the original disks and the promoted disk's current state, dramatically reducing synchronization time and bandwidth usage. Zerto powers off the original protected VMs to avoid a split-brain condition where both sides could run the same application stack simultaneously. The vApp showing as partially running in vCD is due to the vApp container still existing in vCD while both its child VMs are powered off. If desired, both the vApp and VMs can be deleted without impacting the replication process. Both replica and journal disks are preserved. Here we can confirm that the former vApp remains available and the VMs are in power-off state. Meanwhile, the reverse replication is in a sync state. After the synchronization, the VPG protection direction is reversed. We can also observe that the vApp and the VMs are in operational state in the recovery site. The solution also allows you to generate a report containing all the information about the failover procedure. For example, this failover process had a recovery time objective of 2 minutes and 55 seconds. It also provides information about the configuration of the virtual protection group and the vApp networks used in the procedure. In addition, the report outlines the steps taken during the process and the time spent on each. This is a very useful report for compliance and adherence to cybersecurity regulations. I hope this demonstration was helpful and informative regarding the failover process in a vCD to vCD environment using the HPE Zerto solution.